systems. So, Michael, over to you. Thank you.
Thank you very much. Microphone is working. I didn't expect so many people, so thank you for coming, and make yourself comfortable while you're listening to me. Yeah, I'm talking about the benefits of additive manufacturing for defense, which becomes a bit more important recently, unfortunately. Before I start with it, I would like to tell everyone something about Fraunhofer, because in Germany it's well known, but outside from Germany maybe not. It's just a few slides, and afterwards I want to give you an overview about the diversity of 3D printing, because there's so many technologies out there, and then we come to the actual point, the benefits of 3D printing. And finally, I'm going to show you a project which we are working on. I don't want to spoil, I will just go the next slide. Fraunhofer has about 30,000, more than 30,000 employees meanwhile. We have 76 institutes, most of them in Germany, as you can see in all the dots, very spread all over it. And we cover basically anything that you can research. So from AI to manufacturing to biotechnology to, I don't know, whatever you need, Fraunhofer probably does it. There's usually a joke, like our institute is called IFAM, and of course this is a German shortcut. But when you just put an I and 2 or 3 letters in front of it, and you have a Fraunhofer Institute. So there's an IPT, AIPK, IFAM, so whatever letters you use, you will find something at Fraunhofer. We are funded 1/3 by the German government, because we're a non-profit organization, which is dedicated to help industry implementing their new technology into their production, for example, or into their digitalization systems. 2/3 of our financing is coming from third party, so industry or public projects. One more thing, I come from Bremen, which is in the very north left, the green point, if you can see that. What Fraunhofer has done so far, you can see here, the most known thing is probably the MP3 audio compression, which was developed by Fraunhofer or together with Fraunhofer, and also the MPEG-4 video compression in the early 90s. Later in the 2000s, Fraunhofer developed the world record for the most powerful laser. And now in the now times, we have quantum computers, hydrogen technologies, or AI assistants. So Fraunhofer is always tries to be on the edge of the innovations, but also, of course, we don't do it by ourselves. Some things we create ourselves in our minds, but many cases, a customer comes to us, for example, Microfactory, and they are not our customers, but just an example. And they have an idea, but they don't have the capacity or the machines or the time to do that. And that's our business case, basically. All right, so Fraunhofer in general, it's like a company or like it's a non-profit institute, but we are Fraunhofer IFAM. And we have these topics in our institute in Bremen. We are one of the biggest. We have about 700 employees. We have metallic materials, polymers. We cover surface technology, adhesive bonding, automation and robotics, shaping and component manufacturing, where I am situated, with 3D printing, and energy storage converter. These departments are not coincidence, because as I am printing parts, I also need to join those parts. I could do that with adhesive bonding. I need material science for metal and polymers. And also I need surface improvement, or not improvement, or not always improvement, but change. So I can go from one department to the other to help me out if I have a question. So our institute is very big because it needs to be very big. We have many people. We work for basically any industry, mobility, aviation, energy, whatever. And now I want to talk to you about the diversity of additive manufacturing. By the way, I forgot to tell you in the second slide, this is our binder jetting machine, and it's printing the Bremen musicians. I'm not sure if you know them, but it's a nice fairy tale about Bremen if you want to read it. This picture is from my nice colleagues from AM Power from Hamburg. Every year they publish a refreshed, how do they call it, landscape of additive manufacturing. In this case, it's only for metal. The polymer system is even bigger, I think. And all these, I don't think I have a laser, all these technologies have probably their pros and cons. Most of the companies are even here. You can look around. Fraunhofer IFAM, we cover 6 of these technologies. All of them we have in our place. Mainly, or where we have 2 points. One of them is the beam-based additive manufacturing, what you know as laser beam melting or electron beam melting, that we cover. But which is even bigger, or became bigger, is the sinter-based additive manufacturing. So everything that is not melted, or everything that produces a green part in the first place. So binder jetting, mold jet, you may see here with Tritone, and gear casting, 3D screen printing, things like that. The difference is probably here. On the left, you can see the standard scheme for LPBF. It's pretty much the same. You have a laser, solid part, ready, more or less. With sinter-based additive manufacturing, you have only the printer creates a green part, which has the strength of a cookie, basically. It's a cookie and stronger. So if you drop it, it's broken. But the very advantage, or both technologies have the advantages, the pros and the cons. But the sinter-based additive manufacturing becomes very popular because the output rate is very high, although it's not very suitable for prototyping, because you need a few iterations to have a good part. But finally, you can really print a lot of parts, because you don't need support structures, you can nest the parts. It then becomes very easy. All right. There are a few pictures. When I talk about pros and cons, for example, this one with sinter-based additive manufacturing will be very, very hard because too complex from the inside structures. On the other hand, this printing this part without supports also very hard for LPBF. So you have your pros and cons with each technology, and that's why we have 6 of them in our portfolio. All right, benefits of additive manufacturing. I mean, generally, it's pretty much the same as for many others. I mean, the first point is complexity. That's what everyone has advantage of in this with 3D printing. But it's not really complexity. It's the thing that your designers don't have to focus on manufacturability when they come to design a part, and they want to. A part has a function, and you can realize this function without limiting yourself to the manufacturability. Of course, 3D printing has also its restrictions, but much less. So you can design your parts as you wish, basically, print it, and it can be functioning very, very well without any drawbacks. In the defense sector here, you could probably, or I'm going to show you later a bit, you're gonna easily can print brackets, which is also a very usual application, or structural parts to reduce weight and improve performance in general for aerospace, for example. But also just to function, to improve parts in general. Another thing where we, of course, all come from is rapid prototyping itself. All the technology comes from there, but it's still a thing, right? I mean, when you develop a part, if you develop a part and you can see it, you can touch it, you can try it out, and you wait 2 days maybe to have a part, and you can show it to someone and ask questions about it, that's very useful for communication, for development in general of those parts. And of course, you can also print functional parts that you actually test for if the load is okay for this part, and then still you can cast it if you want, but you know it works with 3D printing without having any tools. And here also concerning the defense sector, You can prototype basically anything, from weapon components, armor design, or unmanned vehicles. In-field production, that's very specific for defense. This robot, I would say, this printer is here. I've seen him somewhere. I mean, not this one is here, but a pretty big concrete printer. And those things, not only these big printers, but also the very small ones, printing spare parts, printing individual things for your soldiers, for your machines, for your animals, whatever, can help you to reduce storage and have things around that nobody has thought of before. Like you can have a storage, but the part you need is not in there, but you can print it. And talking about parts are not there, supply chain resilience. If you can print your part, your supply chain can be weak, not weak, but in case your supply chain breaks down, you have an emergency. You can print parts you need for emergency. This again covers especially spare parts, or for example, if you have remote areas, if you have ships where you cannot have a big storage or where you cannot supply very well. Take a 3D printer. There have been projects already where a 3D printer were in a container, or the whole process line was in a container. And they were quite promising. Next one, the second last. Material selection. I'm always a bit indifferent about this one because AM usually have less materials than traditional manufacturing methods. But you can print materials that you cannot manufacture very well. For example, very hard materials are hard to mill, for example, literally. But for example, sinter-based additive manufacturing, it's not a problem. You can put a ton of carbon into your steel. Sinter-based additive manufacturing doesn't really care. Laser beam melting, for example, does care. So you have to take the right technology, of course, but you have the advantage here. It's basically take the right technology and the right material, and you will be fine. This is an example of probably well known from AP Works. They've printed this of out of scalmalloy, which is designed to be used in laser additive manufacturing because it only reaches its specific properties when you print it in laser beam melting. Last but not least, customization. Customization is a thing which usually the fashion industry uses for luxury things, but also for shoes. But also the army can do this in tailoring helmets, tailoring any equipment you need, body armor, tailoring things to your machinery, and also change very quickly things when you don't have a part or it doesn't fit. Change it, reprint it, and you will be fine. This picture is from General Lattice. They implemented this impact lowering structure into their helmets. And one last thing I want to show you is the current research we do. The project is called ROLIAC. What we do there, it's from the European Defense Fund, and we want to demonstrate the benefits of additive manufacturing in general. We want to push this forward because we see the advantages there, and we work within 3 different areas here, which is first of all the design of lightweight and robust components, which can only or mainly be printed. The novel materials for improved performance, especially in terms of bullet impact, for example. Robust and resilient supply chains combined with 3D printing, so that all the supply chain is, so the 3D printers are extending the supply chain, not replacing. And we are a group of, I don't know, a few partners, and it's a 4 billion project, And we have 3 different applications. One of them is this emergency wheel, which you can never have enough of if you are in a foreign, hostile maybe country. And we want to print them and we want to design them as you. This is a conventional part. This is not the printed one, but we want to redesign them so that it can be printed. And the other thing is, for example, this door hinge. This is for the space door hinge. It's for the for aerospace, where they always try to reduce weight. And they also try new materials. And the last one is a space application. That's an antenna mount. This one, it's already looks very additive, and I think it's already additive part. They try to still get less weight out of this part. And with all of these 3 use cases, we check new materials, we check the design optimization, we simulate the production. That's very important. So because even when you want to have an emergency part, your spare part, I don't want to try 5 times to print it. I want a simulation and it should work. And we also have the in and ex situ quality control, which we do for these 3 use cases also. And all of these 3 use cases have different materials, so that all of us, so the sum of our research has a big impact. Let's say that. And last but not least, we have a research in the and the potential of the local production in general. As I said before, with this container thing, we're looking into that. That's it for me. If you have any questions, please let me know. I'm at what hall am I? 12-0 at the Fraunhofer booth. Please visit us, look at our technologies, talk with us about defense, talk with us about anything else you need. We are your research provider, so talk to us. We make your ideas come true, maybe. Yeah, or we try at least. Thank you.
Have time for a couple of questions. If anybody has a question they'd like to ask now. Or where can they find you to ask you in private?
In private?
Yeah, if they have private questions about making their ideas come true.
We have good food in our, we have a booth and there's a canteen inside, so you can find me there.
With beer?
Tomorrow, I think. Yes, tomorrow there will be beer.
Tomorrow it will be busy.
Yeah.
Michael, thank you very much.
Thank you.
Okay.